So I think we have a very full itinerary today. So what I'd like to do is ask Keith if you could share your screen, and you could kick off today and tell us all about airside asset management. We will just, the rest of the panelists, we will all switch off our videos so we can concentrate 100% on you, Keith. So I'd like to introduce Keith Costell, Director for TMS Training Solutions and world-renowned expert on all things AGL. So over to you, Keith.
Yes, hello everyone. Good morning for some, good evening for others, and good afternoon here in that part of Europe. As Robert has explained, we have a really expert panel today. I'm very honoured to be, associated with the guys that have a lot of really good experience and knowledge associated with asset management. So let's really look at where we've come from. Where we've come from over the last few weeks is to really concentrate on safety, compliance and competence, which ultimately gives us operational excellence and helps us to be competent in our job function associated with AGL. So when we're looking at AGL and we're looking at asset management, then we have come from an area where, and I say certainly a colleague of mine years ago, sadly he's passed away now, you say, this is Keith, my English mate, he changes the bulbs on the airfield. And I say, yeah, that's what I do, but we know it's a lot more difficult than that. And therefore, as technology moves forward, we need to really say, how can we demonstrate that we're actually doing a good job? And how can we demonstrate to the regulator, that we are compliant? And so the reality is that when it looks at asset management, and I have to say that TMS Systems developed the asset management for AGL. And so it's a nice little statement on this slide. We say the best way to predict the future is to invent it. And that's exactly what TMS Systems have done. But also it's interesting because we're going to look at the case study from London Stansted. And looking at that case study, I put a little statement at the bottom here. What is insanity? Doing the same thing over and over again and expecting this different results. Well, I think that's what we've done in AGL for a lot of years. We've just carried on doing the same thing. And so when it comes to managing maintenance and managing our asset, and to demonstrate, then this is hence why we have our AGL asset management system of today. But what does it involve? When we're looking at AGL as a system, we've got to have the knowledge associated with what we're doing out there on the airfield, that's working airside and looking after AGL, whether you're installing it or commissioning or maintaining it, but you've got to apply that knowledge as a skill. And we certainly got to have the attitude because, when you're working out on an airfield, it might be raining, it might be cold, it might be hot, it's middle of the night, other people are having a lovely, wonderful time having barbecues away, on bank holidays, but we're working. So we've got to have the correct attitude to work airside. So looking at the knowledge, we've got to have civil engineering knowledge. Pretty clear because we install light fixtures into the pavement. So we've got to have some understanding of civil engineering. We actually then, once we've installed our base unit for an inset light, an in-pavement light, and glued it into the pavement by a suitable resin, then we've got to put our light fixture in. So we've got to secure the light fixture. So we've got to have an understanding about mechanical engineering. And it is an electrical system after all. We power a light fixture. And so we've got to have electrical engineering understanding from power. We've got to understand the distribution. How do we get that electrical power out to the light fixture in the pavement, as an example? And how do we control it? So that's with the electronics. So power distribution electronics is all a fundamental part of AGL. And hence why we've moved forward in technology in terms of how we're going to manage it and how we are as people. So what are we talking about when we're talking about modern asset management? Well, I mean, my era, I came from an era where everything was done on paper. But thankfully, I came from an aircraft engineering world. So as an aircraft electrical engineer, I got used to the development of technology pretty quickly. I migrated then into aircraft support and then onwards into the airfields. And we've seen in more recent years, the data side, the control side of AGL has leaped forward in huge steps and very, very quickly. So we want to be able to, why do we need to have some kind of data-based management system rather than the old-fashioned, paperwork system? Well, we need to be able to make clearer decisions quickly and in real time. And we need to be able to provide that information, not just to the regulator to demonstrate compliance, but also to the stakeholders in an airport, those people who actually fund and invest in the equipment and the technology. And we want to use better use of the staff that we have. So, there's quite a wide range of reasons why we should have an effective and reliable asset management system. But we've got a lot of challenges out there. A lot of challenges is because we've got to maintain an AGL system that is going to be used for different functions, in like individual light control and monitoring as part of an advanced surface movement guidance system of today. And the bigger issue is that there's, well, until COVID-19, of course, that the demand on a runway and taxiways, the percentage of the density of aircraft has increased, tenfold in the last few years. And therefore access for maintenance is also very, very difficult. So if you stay in the old traditional maintenance methods and paperwork, filling in paper and signing bits of paper and then putting it into the office for somebody to copy it onto the computer, it's time consuming and a big issue for us. So hence the need, why an asset management system? And how do we use it? Well, we use it in an electronic format, so that if we do a particular function in the field, and we're going to learn a little bit more about that from Rob a bit later in this presentation, but to utilize it, we need it to be in real time. So if we go out, we need to be able to, it's a bit like Amazon delivering something to your house. You don't sign a piece of paper now, and all they do is press a button, that's it, you delivered, you've accepted it. It's electronic. And way back, immediately, Amazon know it's been delivered safely. Same thing for AGL. We go out in the field, we do a torque test, we do a photometric test, we change a light fixture, we do a cleaning, whatever it is we do, rectify a fault. It's a matter of just, in real time, pressing a button, bang, the records are there. Job done. I mentioned earlier about civil, mechanical and electrical. Well, civil and mechanical, they're the two elements which is really have been outside in many ways, outside the electrical side, because AGL personnel tend to be electrical people. And electrical people have come from constant voltage technology. So to go airside then and work on AGL, we suddenly got this, you need to understand about current-based system rather than voltage-based system. And there is a difference, and we're not going to go into that today. But on the civil side, we need to be thinking about the pavement, and there are new standards coming in from ICAO associated with how we're going to be able to record civil engineering, the state of the runway and the taxiway pavements, whether it's concrete or whether it's asphalt. Mechanical, we're back to this torque tightness. You know, we secure the light fixtures into in pavement or inset lights into a base unit, a can or whatever you want to call it, that we've already glued into the pavement, and they have to be torqued down, a particular torque tightness. One of the big issues that came to me in the early days, he said, "Oh, we don't like this electronic method because that's Big Brother watching us." I said, "No, actually, we can prove that you did the job correctly, because one of the aspects of the electronic torque wrench is associated that unless you torque it correctly in accordance with the model of light fixture, it does not allow you to record the result. And therefore, you're actually proving later you did the job if there were to be an incident." So that, you know, there's some very really positive advantages of having an asset management system. And then, of course, regardless of anything else, we can demonstrate photometric compliance. And we know not only photometric compliance associated with the light output, but individual lights, that we know what the output should be in advance, and so that the system can measure against a known standard. And not only do we do the mobile testing in the field, but also in the workshop. And that's where the asset tagging comes in, because we can tag exactly where the light fixture is in the field, but we also can tag an individual light. So that, you know, from that aspect of things. So I'm going to get on with this case study. And the case study is based upon the airside asset management at London Stansted Airport in the United Kingdom. And here we have to acknowledge, and I think thank you very much to Stephen Ryan, a consultant engineer who has been both the asset manager for the civils and the electricals at London Stansted, and then more recently with as a runway asset lead. And unfortunately, Stephen cannot be with us today. You know, things have changed with COVID-19, and we have to prioritize our function because of that. So unfortunately, Stephen cannot be with us this afternoon. So that's why I'm actually giving the presentation. So let's have a look at the scope of the case study. Let's have a look at Stansted, where Stansted International Airports come from. It's part of the Manchester Airport Group in today's day and age. But how they integrated the MALMS asset management system with MALMS Engineer, the equipment associated with the photometric testing into the day-to-day management. And what it really did is enabled Stansted themselves to justify changing the runway and taxiway lights from tungsten halogen to LED. So it enabled us to show what the savings would be. And then it also helped to demonstrate that when the regulator had identified that the guidance signs perhaps were not photometric compliant, to be able to demonstrate that yes, we agree, and we are now going through the process of changing to LED based signs, and that project has been ongoing, and the asset management system enabled us to demonstrate on those two cases. Number one, to the executive management, but also to demonstrate to the regulator that action was being taken. And then thirdly, in the bullet points here, is IRVR. That's the instrument runway visual range. Now, some of you may not realize that when we report and define RVR, runway visual range, then the equipment that we use to do that has to have an input on the efficiency of AGL. So if you can demonstrate the efficiency and the compliance of AGL at a higher level than the base level, then you can potentially have some credit whereby you can then delay when you introduce low visibility procedures, and that's part of the equation of IRVR. But Robert will explain a little bit more on that. And then additionally, as I mentioned earlier, the civil side, that is now being introduced into the asset management. So let's move on. Let's talk about Stansted to start with. It was actually built as a long time ago in 1942, used for the US Air Force in World War II and the Royal Air Force, and it was then extended in the mid 1950s for NATO use, and then transferred to civil use under the Civil Aviation Authority in 1957, and it became part of the British Airports Authority in 1966, and then migrated, and Manchester Airport Group took over it in 2013. You'll see here, there's 28 million passengers a year, but the key issue is it's over 200,000 aircraft movements. Now, what's important from an AGL point of view is overall is that, number one, it's a single runway now. There's no 3 runways like it's shown on here. It's a single runway. It operates 24/7. That's 24 hours a day, 7 days a week. And therefore, traffic movements per day and etc. is in that 24 hours is really, really important because that controls the amount of time that we've got to manage and do maintenance. So what have we got physically in Stansted? What we have in Stansted, around just on 5,500 light fixtures, both on that single runway and on the associated taxiways, 176 guidance signs, and 134 CCRs. Now that's quite an extensive. Yes, it's not a big 2, 3, 4 runway airport. It's a single runway airport. Now, this is pretty extensive, and what we have there is a structure of how we put together the maintenance team, and there's 4 maintenance teams, and if you see here, look, 1, 2, 3, 4, 3 persons in a maintenance team on a shift, and that rotates on a cycle, supported by a day team. Now that's it. So anything that is associated with the airport then is managed by those guys. Now here's a picture. Look, I took it taken off. If you went on to the Google Earth, for example, and zeroed in, and this is basically what you would see. So single runway, associated taxiways with stands. Stands are next to the main terminal and some remote stands, and therefore. That's what we got. So where have we come from? Where we really come from is that to integrate MALMS into the maintenance management system, then we started off and we're doing photometrics, and that started off around, I don't know, about 2001, something like that in Stansted to do photometric testing. But it wasn't until 2016 that it started to integrate into an asset management tool. And so it was really before that a standalone. Now it's in 2016, the integration into MALMS Engineer came along. And MALMS Engineer has allowed us then to build up a complete register. And when I say a complete register, a full register and an accurate register of what we got in the field. And when we're looking at photometrics, and those of you that do photometrics, you will recognize the graph, the little bar chart we're showing here, where green demonstrates a compliant fixture, that is above 70%, not yet needing maintenance. The blue is between 50% of light output and 70%, which demonstrates you should be doing maintenance, and the red shows it's below 50%, then that is a non-compliant location. So that's the scenario how we look at it generally. Now, this criteria is shown in ICAO's Aerodrome Design Manual, Part 4, Chapter 17. So I suggest you have a look at that. It's good because it demonstrates what asset management is all about. It is known by ICAO and as differential maintenance. So here in Stansted, we took the MALMS Engineer and then we were able to produce spreadsheets. Spreadsheets, firstly starting with task functions, etc., for electronic monitoring, recording, etc. And it started by introducing first the runway, all the services on the runway, then the taxiways. Now we can, with the upgrade of the signs from the traditional signs into LED signs and the elements of CCRs, insulation resistance values, etc. So all that now can be inputted in into the system. As I said earlier, it demonstrates compliance, and what we can do is extract, and Rob is going to go through it a little bit more intensely afterwards, but what we can do is extract out and present it in many ways. And whether you want it on a spreadsheet, whether you want it in an email, whether you want it on a bar chart, there's different ways of presenting the accuracy. And what it is not just accuracy, it's the repeatability upon demand in real time. So we're in this period of checking performance, and performance in a basically a progressive way, so that we're going to be looking at maintenance not by saying, okay, we'll do it every day, this task every day or every week, or I think the light looks dim, I think we'll have a look at it. And we still do those kind of checks, they still do the runway checks down the runway periodically, and then if it looks as though a light fixture is dim or out, then it is recorded still in the same way. That doesn't go away, but what we can do is input all the methods of being able to test compliance, whether it's cable damage, whether it's an earths on the circuit, whether it's a photometric, or whether a bolt has been recorded as coming loose. All those kind of things. We can measure the performance out and record it in real time. And what is interesting, I took a picture look of a junction here. This is a crossroads, and out on the taxiway network. Now that's really good, because what we can do when it talks to fault, we can then prioritize. We can identify all the fittings with the assets at the location. So we've got a really clear picture of what's out there. But we can also put some colors in. You can put your own colors in, but you can put colors in associated with performance. So we can tell which light fixtures are actually underperforming or in fact unserviceable. So you can customize this. Clearly, it's quite pretty logical if we follow the same concept of red if it's unserviceable, blue if it needs maintenance, and all that kind of thing. We can, it's configurable. And Rob will explain a little bit more about that. Moving on, just to re-emphasize that. How did Stansted utilize the introduction of this asset management, the MALMS Engineer and the dashboard into the maintenance management system? Well, one of the aspects previously was the fact that we were doing maintenance. Maintenance was being done, and it was being done by an effective team. But how could they prove it? And how, when it came to saying, well, can we now transfer and migrate from tungsten halogen to LEDs? There is a drive in the industry to do that, and it won't be too long before manufacturers will no longer offer tungsten halogen at all, and potentially not even to support them. So we've been driven down the LED route. And so to demonstrate why, if you've got the records, you can demonstrate how the introduction of LED is saving actually money. It will pay for itself. There will be a return on investment. And so LED fixtures are more expensive than a tungsten halogen fixture, but the return on investment is pretty quick. Now, all manufacturers claim different returns on investment periods, but it is you know, well, it certainly helped Stansted. It most certainly helped, and it helped them for the decision of getting some of the capex money, of where and capex, for those people who not really understand, it's where it's the overall capital expenditure associated with how you invest into the future, and so the migration to LED was part of the capex. So what is that, the real value? Well, assumptions. Previously, with the paper era, then it was always based on assumptions. Oh, let me show you this, let me show you that. And so it's really has strengthened the business case, and be able to demonstrate that the asset as an AGL, the asset itself as an AGL, has definitely improved and saving us money. And I think this one is this graph here is a pretty good indication. And let's take you know, the blue line here, which is it's down here. Look, as MALMS low intensity. What that means, that is low photometric output. There was a gradual decrease in its in the light's efficiency, which means that more and more maintenance was, and more faults were being reported, until we got to a stage of replacement between tungsten halogen and LED. Now, some of this was associated, oh yeah, we cleaned, then it deteriorated, then we cleaned, then we deteriorated, then we cleaned, then we deteriorated, etc., and other maintenance. But once we got to the LEDs, it's been a dramatic change. So it's a really good, a good function and a good decision to have an asset management system, however complicated our airport is. And then we moved on to, I mentioned guidance signs. Now in guidance signs, then is this here where it really did come into its own. Number one, though, the regulator had identified, and if you see here, look, this is what they used to be like. And the regulator said, I'm not too happy with those. But also there were reports back from pilots saying, I'm not too happy with the guidance signs. Which way is hotel, for example? But now that's what we've got. So there's a dramatic change. And I think this is a good time for me to say, Robert, maybe you should, this is the time to come in, because it's this migration from tungsten halogen to LED, but it's also the demonstration for IRVR credits, which is a UK based thing. So Robert, maybe you'll come in now.
Thank you, Keith. Excellent presentation as usual. Yes, so as Keith says, we were involved very much. We work with airports to help them. I mean, a lot of the initiatives have come from MALMS Engineer developments from our airports, our customers who need the information. Increasingly, if you have a problem with, as you say, with signs, you need to get capex to be able to invest in them. So you need to do an evaluation to determine, because I believe we're talking about several £100,000 in the case of refurbishing these. But you have to compare the investment decision to replace or to upgrade. And then with TMS, we provide the monitoring in terms of the results from the inspections, to support the business case. We also provide the tools to provide the measurements. So and we'll be talking about this in a minute. We have a sign testing piece of equipment, which some of you are aware of, that we're now using at airports. It's not released for customer use yet, but it very soon will be. But that is currently being operated by TMS, and we're measuring signs, and Stansted, and there's Marcus Jelliman there. We worked with the team there to evaluate the performance of the LED replacement light sources on these lights. So as Keith says, looking on to the next project, AIRVR. This is an issue affecting airports all over the world, because runway visual range is calculated via the equipment in the forward scatter machine or the transmissometer. The disseminator, part of that equipment, uses a formula to calculate what the runway visual range, to report that to the tower, and that's a critical safety factor, accurate reporting of runway visual range. And inherent in that calculation is the intensity of the value of the intensity of the runway lighting. Now that is an assumed value. So if your actual performance is below that assumed value, then you will be overstating your runway visual range, and you could be potentially contributing to a very dangerous situation. Conversely, if your actual lighting performance is better than that used in the runway visual range equipment, the AIRVR calculation, then your runway visual range will be understated, and you could be preparing for low vis or going to actual low visibility operations unnecessarily. And of course that has a significant cost for the business and for the airlines using the airport. So maintaining your lights to a serviceable standard, to the standards specified in your runway visual range equipment, is absolutely critical. So we've been in the UK because of this, the risk associated with overstating runway visual range. The civil aviation has a process whereby they insist on a very low figure being used, a base level figure for runway lighting intensity, unless the airport can demonstrate good maintenance by means of MALMS photometric reports, which if they can show sustained good intensity of lighting, then the figure can be uprated, and the disseminators reprogrammed, and the airport will consequently go into low visibility operations less frequently. So we're working with many airports on projects like this, and Stansted is one of those. So that is currently in process. The next thing that Stephen and his team were looking at was the reasons for low performance of the runway lighting. Having got LED lights, there is a view, misconception in the field that runway lights can require no maintenance or little maintenance if they're LEDs. However, they still suffer the contamination from the atmosphere, the environment, and of course from planes, and in winter and cold climates from de-icing fluid. So they need to be cleaned. And cleaning methods have been tried numerously. Walnut shells are a method that's been tried. Pressurized steam washers, dry ice, and unfortunately for many of you guys out there, getting on your hands and knees with a bottle of liquid and a cloth. But all of these methods have proven to be, well, they're suboptimal, and with the result that you have to, even if you can be effective, you have to do it more often to actually achieve the required results. And so as a result, CMS some years ago were asked to develop a solution, and we came up with a bicarbonate of soda pressure cleaning system. Does not use any fluids. It's biodegradable, the powder. It's highly effective. It's used, we discovered it's actually used for cleaning of architectural buildings, and it is now being widely adopted. And Stephen Ryan has taken the machine into Stansted and has shown very, very good results. And even though the team there are hugely diligent with manual cleaning methods, you can see from the chart on the bottom left, using the MALMS cleaner, they were able to achieve their best ever photometric results. So not only, whilst they were compliant before, they are even more compliant, which means the required maintenance is, the period of maintenance and cleaning is less frequent. And of course, for a single operation airport, that's a highly critical factor, you know, to improve runway availability. You do not want to interrupt operation. You want to interrupt operations, not at all ideally, but certainly as little as possible. So other areas of benefits from the measurements, as Keith has been pointing out throughout this whole series of webinars, you cannot manage what you do not measure. So actually capturing digitally the results of the work you're doing to maintain your runways in all respects is vital to asset management. That is the basis for your asset management, for your decision making, for your business cases. And one of the benefits they've found is by actually recording the performance of their assets, and for example, their lights and the components used in their lights, is they've been able to hold manufacturers accountable for aspects of the supply. And they've been able to identify particular performance issues and measure them and present real-time information to those involved, and to constructively engage in rectification. So it's proven very, very useful to Stansted and other airports. The next area is civils. I have to admit that when Stephen came to me with this, and also our colleagues in Doha and Manchester to include civils in the MALMS system, my heart sank a bit. We were so busy, but we're driven by our customer needs. And so as if we didn't have enough to do, the team embarked on developing a civils package, which has proved extremely effective. The problem was, once again, that the systems they had available weren't particularly user-friendly. They were also, in relation to civils, they were very static. That the process was there were periodic surveys done, stuff recorded, and nothing was actually done real time. The tools are more in the nature of an audit, or every 1 or 2 years, and then go through a planning process, as opposed to real time capturing information. And what happened was that airfields that were doing their MALMS Engineer inspections using the tablet, they were seeing faults on the other faults, civils faults, and saying, well, why can't we record them on our tablet using our camera facility? And so working with our colleagues in the airports, we have developed the MALMS civil engineering package, which has been highly effective, and you saw, and you'll see that, you know, in relation to Stansted, they've actually developed some very new very market leading, I think, or some very effective methods of patching and doing selective resurfacing that has actually worked remarkably well. The traditional methods, as I said, were annual surveys going along with architectural type equipment, and then MALMS, we've come along and we use our tablet to record using the airfield map, logging the faults real time, recording the individual areas, and we've developed a series of enhancements as to meet the needs to categorize the different sorts of faults, to layer those faults to whether when they've been identified, whether they've been fixed, how they've been fixed, the different types of defects, and then to use that information as part of the planning process. This has been, as I say, this is a learning process. We've been developing this real time with customers, but I'm very proud to say, we have a very responsive team, and the tool has evolved to be something to give a very positive outcome for certainly for Stansted Airport and others. In particular, just very briefly, because we're running short of time, what they've been able to do is to record the patching of civils faults, but then hold that information and use it to plan more serious resurfacing efforts, larger civil engineering projects requiring full closures, where they've actually been able to take up, based on the information provided, sections of pavement, and then in a two-layer process, replace those areas, and those faults, which would traditionally have been requiring a resurfacing of the runway, have been shown to last, certainly I think some of them up to a couple of years now, without any sign of fault. So it's been highly effective, and I think very certainly worthy of investment at Stansted Airport. But we're not stopping there. We're continuing to develop the process. I've been asked to look at integration with some of these the traditional asset management packages or pavement civils packages, such as micropaver, and we're in discussion with them. So watch this space. Like everything, what was good enough today is not good enough for tomorrow, and we're looking to keep up with the times. So it's a foundation for asset management. It's a foundation for future investment, and but you can't do any of that unless you can support it with the business case, which requires the measurement information to show to measure the problems and to show the effectiveness or otherwise of the solutions being employed. So, looking forward, as I said, nothing ever stands still at Stansted and other airports. We're now looking to track the performance of the fittings, not just the location. In the past, we look at a particular place on the runway, a particular location, a particular service. But now, given the investments in all of the equipment at runways, we're looking to track the performance of those assets and manage the maintenance of those assets. It's the whole life cycle. The runway is an asset, the AGL are an asset, the signs and the PAPIs, and they all have the same characteristics. They have to go through an acquisition process. So you need the measurement data to support the investment. They need to be brought into service. They need to be checked for compliance on installation, and then monitored throughout service to make sure they're achieving the standards required. And then at the end, they have to be maintained, and there's a cost associated with that. So when we're looking at an asset, we have to consider the whole life cycle of the asset, from purchase to disposal, whether it's a runway, an AGL, or signs and PAPIs, or any other equipment you might have. And so we're tracking now the performance of the AGL with an RFID tag, as well as the location. We're looking also at the photometric performance, not just on the runway, but also on the taxiways. We're looking at photometric performance of PAPIs and signs, and we have the capability to measure those and monitor compliance. And it's very important to note from the testing we're doing when it comes to PAPIs, and we'll have Tony Smith will be leading a masterclass on the topic. As you know, Tony Smith invented the PAPI. He's presenting to us next week. the performance of the PAPI is not just about putting a clinometer on the PAPI box and making sure that box is at the right angle. The actual setting angle of the projector inside needs to be what it's supposed to be to give the correct visual cue to the pilot, a crisp signal, too high or too low. Therefore, the transition has to be within the prescribed parameters, so we need to measure that. And of course, you have to measure the intensity of the PAPI. We've seen a number of PAPIs where they're actually, they require relamping, but without a measurement, you wouldn't necessarily know that. And then finally, they have to be compliant from the perspective of color. The red has to be red, not pink, and the white has to be white to give the correct cue to the pilot. We're also working with airports to provide interfaces to enterprise asset management systems, such as Maximo, and we're working to link into and to link the dashboard into to provide information from the control system, various manufacturers' control systems. We're also looking to monitor approach light performance, and we have a tool that can do that, which we're volunteering to trial very soon in the UK. And finally, we're looking on the airfield, on the civil side, to develop those systems further and integrate with PAVR. So there's a lot going on at the moment, but it all comes back to the fundamental basics of asset management. And we term it in TMS the differential maintenance process. You have to have the measurements. Based on those measurements, you do your maintenance. You monitor the effectiveness of that maintenance, and then you manage the overall asset management process to optimize the output for safety and compliance. This, as I said, is MALMS differential maintenance. We have the tools to do the measurements, the MALMS photometric systems, the torque management systems. We have the tools to support the maintenance, the recording tools to actually capture the data. We have the cleaning systems now, and then we have within MALMS, within the MALMS cloud and reporting, the ability to monitor and manipulate the data and manage it to achieve the optimal output. So and I unashamedly will not stop repeating this, you cannot manage what you do not measure. So of course, this all brings us nicely to the MALMS Engineer and dashboard. And I'd like to introduce you to Rob Billingham, if you'd like to flash up your screen there. Rob is the mastermind behind this, and you know, as I said, I'm so proud of the team. And he's produced this wonderful dashboard supporting the information from MALMS Engineer, and he will now take you through some of the functions and features to understand how we turn the monitoring into asset management. Rob.
Thank you, Robert. Good afternoon, everyone. Yes, I'd just like to take you through briefly the dashboard and the MALMS cloud, to give you a flavour of what's available and how it can help you. We could do a whole afternoon on this, and I think we're planning that in a future week. So I'll just keep it brief today, just a flavour of what we can offer. So next slide, please. Right, so what is MALMS dashboard? It's a business intelligence analytical data visualization tool. So it shows the status of metrics, KPIs. It's used to view all of your MALMS Engineer photometric testing and your photo bench data in one single place. Provides access to a whole library of reports, shows live information as we'll discuss shortly, and it runs from our MALMS cloud server. So first of all, you need to understand where we've come from. To start off with, we had a tablet PC and a trailer, and we collect information on a photometric survey. Then you take the information from this tablet using a USB stick, transfer it to a laptop, where you'd leave it in the cupboard for another year, produce some reports when it's time for for your regulators to see what's going on, and that'd be it. But now we can transfer this data to a cloud. It's there all the time. It's useful. You can use it in your day-to-day job, and it can aid you. So I'm going to show you how that can be done. So next slide, please. So first of all, benefits of the MALMS cloud. First of all, secure. Your data is now backed up in the cloud. So previously it was on a laptop, a USB stick, could be lost. It's on a secure server. It's professionally hosted, and it's got all the latest security features. Huge benefit, the data is backed up, so you cannot be lost. Our support departments have access to this data, and they can help you. They've got access to your logs if you have a problem. You can review the data with them. Also, if you need some help with commissioning new runways, it's all there, and that can all be done very quickly and more efficiently. Then you have the dashboard itself. It's live data up to the minute, data on inspections, photometric surveys, talking, cleaning, photo bench, every aspect of the MALMS system. It's up to date and live. It's customizable. We were talking just before the meeting started about building a modular system as you progress. So you can start small with just a few things on the dashboard, perhaps just your photometrics, and then you can grow. You can add more and more there. Your reports, there's a whole library of reports there. You've got everything from the old MALMS office available. Everything from Richard's earlier reports on MALMS Engineer. You've got management level reports, reports for engineers, the map, all sorts of things. I'll talk about it a little bit more in the coming slides. Analysis, you've got statistics, fault analysis, trends, and it becomes part of the overall MALMS differential maintenance package. Email is a recent introduction. Your reports are available instantly in your inbox for breakfast. You do a photometric test, the reports are there for you as soon as you come off the airfield. You don't have to even log on anymore. You can have regular emails coming in on a daily basis, weekly, monthly management reports, or reports when something happens, like an inspection is completed or a new fault is reported. So system integration, we've been integrating MALMS Engineer now with other asset management systems, particularly in the Middle East. We can interface with SQL, XML, or JSON interfaces. We can also transfer data quite simply into Excel, so you can pull your data into other statistical packages that you may use. For audits and compliance demonstration, our reports are respected by regulators. They're used to seeing them now, and they like them. When we can prove compliance with ICAO, FAA, or MADS. Next slide, please. Okay, so this is the dashboard itself. There's lots of information there. This is user configurable, and it's modular. Each panel shows a different aspect of the system. You've got your photometrics and runway serviceability, and then you've got your IRVR, which Robert's already spoken about, your photo bench, talking, cleaning, inspections, preventative maintenance. And each panel is broken down to runways or areas, and then an overall summary for the whole runway, whole airfield, sorry. We also have alarms to draw your attention to things that are going wrong. If a level has dropped below, so stability level has dropped below configurable amounts, you'll see a little red warning shriek pop up. So it's similar to on a mobile phone. So draws the eye to that, and these things are available in a log as well, and an email. The icons which are all over the dashboard allow you to drill down into an area or runway and look at further reports. So next slide, please. Okay, so for photometrics, from the old MALMS office system, we've got runway serviceability, which is a bar chart broken down into service types, centerline, edges, TDZ, runway ends. And you click on one of those and you come down into your course bar charts, which we've already looked at, staple reports, which engineers are used to looking at. And then you can drill down again into the isocandellas, look at what's going on with an individual lamp. Next slide, please. We've recently added a new report, it's called Survey History. And the idea for this originally came from Dubai. They asked for some tabular data based on previous surveys. But then we've worked on this with Heathrow, had some excellent ideas. So for each lamp, we have a grid of information which shows data for the last 12 surveys. So if you only survey once a month, that would be a year's worth of information for the front side course and for the reverse. So for each cell, we show a percentage of standard the lamp has achieved on that survey, and we color code the cells so you can easily see where it has passed, where it needs maintenance in blue, or where you have a failure in red. We also show an average, and we show a form factor, which is the number of times the lamp has dropped below maintenance level during the period of 12 surveys. And then next to that, the number of times it's failed recently. So almost like the form for racing or for football. And you can pick out the lamps which are failing over and over and get them sorted out. You might have a lamp that's in the wrong way. It's always been like that. And you can see that straight away. You could pick up on circuit faults as well. You might have every other lamp showing a problem. So that's something we've recently introduced, which we hope is going to be useful. Next slide, please. So for MALMS Engineer, from the dashboard, we've got information for torque, cleaning, civils, inspections, and all these things follow the same consistent layout. We drill down from an area into zones and then into individual assets. Each report has what we call the quick filter bar at the top. So you can easily move to a different area or zone without having to go back to the top level dashboard again and start again. And we have what we call our share button. This offers all of the printing, export and sharing options. You can instantly share a report with a colleague now. So all of this sort of stuff is there to help you with your day-to-day maintenance. Next slide, please. So for airfield or civils, as we talked about earlier, on the tablet we record a fault and we have photographs and comments associated with it, and it builds up a log of the job as the fault progresses from when it's first reported to when it's closed. We've developed these reports with STANSTED further. So we've added severities, low, medium or high, and we've added further statuses. We've got open, monitor, immediate action, long-term action, and then eventually closed. And all these things are now available as filters. So you can produce a report of exactly what you need to be working on. Okay, next slide, please. So recently we've integrated the workshop tester with MALMS Engineer and called it PhotoBench Engineer. So we're talking about when we tag fittings and we can track them. We know whether they're in the runway, in the workshop, on the shelf. And this sort of asset tracking enables us to come up with nice things like mean time to failure, mean time to repair, all sorts of new statistics. And it's brought your PhotoBench Engineer operations into the cloud, and all the data's there and visible. Next slide, please. So for management level, for top level reports, we have the executive summary, most useful as an email type report, maybe every week or every month, drops into your manager's inbox. And it's a summary of all MALMS Engineer and photometric activity within the particular time frame. So how many faults have been reported, how many have been fixed, how many are outstanding, how many inspections have been completed successfully, your talk summaries, all that sort of thing. It's a complete summary of everything that is necessary to know at management level. Next slide, please. So the map is a big part of MALMS Engineer and MALMS Photometrics, and it's a tool available on the tablet, but it's also available on dashboard reporting, and it's yet another way to view the information that's available. So we have layers for MALMS Engineer, Photometrics, and Civils. So we based the whole thing on an ESRI map, which is something you may be familiar with from other asset management systems. Information is available by clicking on an asset on the map. Faults are color-coded, as we've already mentioned. You can run reports from here for individual assets or for courses in photometrics. And you can also make simple remedial action scheduling and management level actions from the map too. Next slide, please. So if you find a particular asset on the map that you find interesting and you wish to investigate it further, the asset information report is a complete breakdown of everything that's happened to that asset within the specified time range. It's a complete audit trail. So you've got a summary of the last 10 faults, recent talk readings, has it been photometrically tested, what the results for each side, has it been talked, has it been cleaned. So it's all available as a complete summary. Next slide, please. So on additional pages, you've got the photometric summary, complemented by logging of replacing AGL and by cleaning. So you can see when the lamp's been replaced, you should expect the photometric result next to go up, or if the lamp's been cleaned. So you can monitor over time, and you can see how often you may need to clean or how often you may need to re-lamp. We also show, of course, bar chart for the last test that lamp was involved in and its latest Isocandela drawings. Next slide, please. So something else we can do with the map, we can create heat maps to show fault or action hotspots. So where on the airfields are faults most occurring, or where do you have to do most actions, most re-lamping or most cleaning. And all this analysis can be done from the map. Help you plan your preventive maintenance. Next slide, please. So another use for the heat maps, a recent development we worked on with Amsterdam. If you calculate an average degrees of movement for a lamp, for a bolt, when you torque it, you can start to build up a picture of where you may need to torque more often or where you don't need to torque less. So you can concentrate your efforts on areas of the runway which need to be maintained more often. So for instance, lamps within the TDZ, the plane wheels will hit them more often, or on the taxiway corners. And these will show in red or amber, and lamps that need torquing less will show in white. Next slide, please. So for the airfield, we've done some development with Stansted, as Robert's already said. So we started off by building up the application on the tablet. So the guys were logging a lot more information, doing severities, and more information about the status. And we reintroduced blocks as well to break up the runway. So airfield faults are now contained within zones and blocks. So this color coding now matches the tablet application. So next slide, please. I've already mentioned email reports. We've recently done an overhaul of this system, so it's a lot more robust and future-proof for more volume. So you can configure reports to arrive in your inbox weekly or daily, monthly, whatever you want, or when there's a particular event like an inspection's completed or a photometric test has taken place. And these arrive as PDF attachments on an email, and you can set these up so they go to your whole team, to your management as necessary. So we can help you configure these if if you need that. Next slide, please.
Right. Well, there we go. That was a very, very brief summary, even though we've run over time. I hope you appreciated that. Obviously, Rob can be, and TMS, we can be contacted, and we're happy to give individual airports, individuals, a presentation on this information in more detail. And if you have some or all of our systems, we will do it specifically using your data to help you understand and interpret more. So we have got coming up in the next couple of weeks, much look forward to a lot of positive feedback for this. Tony Smith's PAPI Masterclass will follow with a panel of experts afterwards to hopefully answer all your questions. If you do have any questions in advance for that, so Tony can prepare, please send them in. MALMS TMS Training Solutions, info@tmstrainingsolutions.com. The web address is on our invitation. We have, following that, an AGL serviceability, compliance, and causes of low performance presentation, which I think, again, this has been requested by some of you out there. So I hope you find that very interesting. But if there's any more, unfortunately, we are, this is not we're locked down for a while. If you're finding this helpful, you'd like to know more, learn more, please share your questions with us, and we will do what you want us to do. I'd now like to bring on our panel of experts. We have Keith, who you know very well and have seen over a number of weeks, Rob, who's just presented to you, and of course those of you that have worked with us for a while will know Richard Gore, who's anonymous at the moment. Richard, where are you? Come back, wherever you are. Right, unhide yourself. And Paul Smith, who you will also know from many photometric commissionings and testing and trainings across the world. So what I'd like to do now is to get rid of my presentation so you can see the panelists more closely, and to ask them. Hello, Richard. Sorry, I couldn't see before. And to ask some questions. What I propose to do is to go on for about 20 minutes for those that can. I know it's running over time, but these are your questions, so, and I hope you find them useful. Right, first one here I have is a question from Tony Coates. It said, when you brought your sign tester down to Coventry on trial runs, it was able to show that even on a now general aviation airfield, cleaning the signs could show a 40% increase in light output. I mentioned that's not a question, but I'll just reiterate what Tony says there. It's maintenance of signs isn't just about repair, just about changing the tubes or the LEDs. It's about keeping them clean, and we got a 40% improvement from. Or Tony got a 40% improvement from cleaning the fascias. Right, the next one, which is the basic information you would need from an airport to start developing a solution for it? Well, that's a very broad question, but if I could ask Paul Smith, so start thinking very quickly, Paul. The question is, if you haven't got any measurement tools, where would you start?
Well, I think the basic one is one of our oldest products. It's been used worldwide for many years. Is to start with a photometric trailer, so that you can actually start to measure the photometric performance of your AGL. We can, as Rob has discussed recently, put all of that information from your photometric surveys onto the cloud. You can then sit in your office and use your favorite web browser to start to analyze the data that you're getting back from there. And you can start to see how compliant your runway is and what you need to do in terms of maintenance. In order of what information we require in order to do that, generally speaking, we can start off with an airfield drawing, and then we will work with you to determine what types of assets you have. For example, is your runway edge an elevated runway edge or predominantly inset runway edge? And so basically, once we've got that kind of picture of your airfield, the spacing between the fittings, any oddities that you may or may not have, we can then do a general photometric survey, which then gives you a basis to start collecting data from your system. From there, I would then suggest that maybe you would start to look at tagging those assets and having a torque wrench so that you could do torque checks on those assets and get the information back from there. And then from there onwards, it's really, you know, as much as your budget will go for, and you can have as much or as little of the system as you need. But I think predominantly I would start off maybe with a photometric trailer.
Right. Okay. Thank you, Paul. I have a question now, and one doesn't generally want to air the challenges and the difficulties, but I think it's important to note that when you're working on an airfield, collecting and measuring data, that it is not an easy task. We're working with technology, we're working with Bluetooth, we're working with 4G, and we spend an awful lot of time working out the best tools and configuring and working out how to make these things work optimally, given that, you know, we're in a lot of cases not specifically responsible for the, you know, some of the component parts that we rely on to deliver your solutions. Richard, what sort of connectivities do we have with Bluetooth and 4G, and how do we overcome those problems?
Well, in Bluetooth, is fairly limited to maybe 10 meters distance. But generally speaking, we use Bluetooth between the tablet and the stick reader, and also between the tablet and the torque wrench. Providing you keep within the 10-meter distance, we don't really have any issues, really. It works within those confines, whatever. It takes a little time to connect sometimes. That's probably the biggest issue. You know, you can take sort of 10, 15 seconds sometimes before it sees the stick reader after you turn it on. So that would be my biggest issue with Bluetooth. Other than that, you know, you turn it on, it connects, it works really. 4G, again, we only use 4G. Well, you know, again, if provided you've got good connection on the airfield with you know, the network, then no issues really. I mean, 4G works very well. They connect from wherever you are in the world to our server, and you know, works very effectively. But the issues start to come in where you don't have very good you know, network reception out on the airfield. But that really is down to your, you know, network provider. But the tablet doesn't need 4G connection to work. It's not that if you lose 4G connection, the whole thing falls apart. You can carry on collecting data, you know, doing all your inspections and all the rest of it, doing your photometric, whatever. And then when it sees the 4G there, it will then connect and shoot all that data up to the cloud. So you don't need an always-on connection. So from that point of view, we can work around difficulties with the 4G. We can even work without 4G. We can just use wireless in the office so that you can go out in the airfield, do all your inspection, and then when you come back in the office, it will see the wireless in the office, and then we'll connect to the server and you know, transfer all data. So that's the way we overcome the issues with 4G. So that's my answer really. Is there any more questions on that?
Personally as well, I've actually just tethered when I've had potential problems with coverage on networks or Wi-Fi. I've quite successfully tethered the tablet to my mobile phone and just use my mobile phone as a hotspot.
Yep.
Yes. So next question from Mohammed. I'll ask Rob this one. How much data can you store on for an airport with MALMS dashboard? What are the limitations?
Well, we've got customers like Stansted that go back to 2001 on their photometric side with data collected by the trailer. So we haven't really hit any limits on that. We have, if there's a lot of assets, we have archived photometric data away just to speed up the reports a little, but certainly we should be able to accommodate all of the photometric information. On the MALMS Engineer side, we are SQL Server, so we don't really have an upper limit that we've hit yet. In terms of assets, we've got airports with 16,000 assets on the airfield. So I don't envisage any upper limit on that either. All the reports are set up for historic. You can set date ranges for the data you want to pull. So you can pull just the last month or the last 3 years. So we are set up for historic data as well. So yeah, my answer is we don't know an upper limit just yet.
Right, and we do, just to be clear, I mean we do run, I think the largest airport runways, we have seven runways, I think, which is 14. Yeah. 14 at obviously 2 directions. So we do multiple runway airports, and we haven't struck any ceilings yet.
No.
But yes. So we'd like to. I have a question here on the MALMS. Well, I've got a couple of questions for Paul. How long does it take to clean a runway centerline with the MALMS manual cleaner and the MALMS automatic cleaner? And that's for 200 lights, 200 bi-directional lights. And another question, is the MALMS cleaner bi-directional?
Okay, yeah, good questions. Did you say 200 fittings?
200 fittings, yes.
Yeah, for a 200 fitting, I would suggest that you probably need around about 1.25 hours for a manual cleaner, and maybe 1.75 hours for an automatic cleaner. That would be a complete clean from end to end of a runway. And the automatic cleaner takes slightly longer than the manual cleaner because it has an automated process that it goes through to identify where the lights are and do the cleaning. The manual cleaner obviously requires the good eyesight of the operator to do that. Both systems you can clean from stopping at an AGL. You can clean both sides of that AGL at the same time. But what I would say is you wouldn't normally do a complete 200 clean in one go. Maybe you do that as a deep clean to start your maintenance regime off, but using the photometric trailer in conjunction with your cleaning system, you would look at the reports from your MALMS surveys, and you'd only actually bother cleaning those fittings that really needed to be cleaned. So those that were appearing in your course bar chart, for example, as blue or red bars, and the ones that were already clean, you wouldn't do that. So you wouldn't need to use the cleaner for very long at all on the runway. You probably only need to use it for around about ½ an hour to go out and do spot cleaning as you went up and down the runway centerline.
Okay, thank you for that. A complicated question for Keith. SMG and CS ops and runway protection systems use AGL. Hence, can we add a specific facility for checking, reading, and demonstrating compliance with an autonomous runway incursion warning system?
Well, I think that question really comes up. It's something which is runway incursion is a major safety issue. Runway incursion comes from vehicles, it comes from aircraft, etc. So the system that is now is being used in mostly in the US is the runway status light system. And what we're really saying here is that because it's a safety critical, how can we differentiate that in the AGL into the MALMS Engineer and into the dashboard? I mean, for example, we're integrating now. You can put the insulation resistance values of the electrical side for circuits. We talk about in the civil side, but when we're talking about surface movement guidance and we're talking about runway incursion protection, that is associated in and around the stop bar with the lead on, lead off lights, for example, lead on lights for runway incursion, and from that aspect is it would be logical for us to have a dedicated little package associated with that, so that when an alert comes, then it's recorded exactly that the facilities, the lights that are included in that process are actually working and efficient. So it's a level of efficiency. I think I think that maybe that answers that question. There really is a key issue, runway incursion. There's more runway incursions happen than we actually realise.
Yes, it's a feature of many of the conferences I go to. It's a constant problem, and with unfortunate consequences on rare but significant occasions. One for you, Richard. Can MALMS integrate with other systems such as enterprise resource planning and AGL control systems?
Well, I guess the answer is yes, really. Technically, it's all feasible. Not terribly difficult thing to do typically. I think it's much more difficult from a organisational, political point of view than it is from a technical point of view. And I would take, we did a project in the Middle East where we were linking to Maximo, and we actually had a proven technical solution. We could show the works orders coming from Maximo into MALMS Engineer, etc. But the whole thing then fell apart because we couldn't get their IT department really to get involved and implement it. Originally said that they were in the process of upgrading the Maximo from versions one version to a different version, and after that the whole thing just died a death. So I think that's the difficult part of doing this, is really just getting the buy-in from all parts of the organization, rather than the actual technical part of actually writing software to do these things. We also have a project to link to an Oracle ERP, which again has sort of died a death because of COVID and also issues at the other end, etc. So that also was sort of stalled for the time being. Then we are in the process of developing an interface to a Honeywell control system. So I mean, these things are feasible basically. So it's just a question really of overcoming the political organizational issues to get them installed.
Well, I'm delighted to hear that answer, Richard, because the whole world has just heard that software is the easy part. It's the politics that's the problem. So
No.
I will remind you that next time we get it.
Software information, the software bit is easy. It's the actual, it's implementing it, getting people trained, getting people to buy into it. The software bit is relatively straightforward.
So yeah. So I mean, it is. I mean, there are a number of we've done this at a number of levels, and it's great to it's good to be able to use the information from third-party systems in the dashboard, so you can see all your key performance indicators in one place. Rob, I have a question for you here. You talked about IR/VR. How can we demonstrate our IR/VR results using dashboard reporting?
Okay, so for day-to-day monitoring, you've got the dashboard panel itself, shows you the current percentage for each runway. Then you can drill down into a bar chart, which I think we saw earlier. So that shows the level you're trying to achieve and the current average level across the surveys you've completed in the last year. You can drill down again into a line graph, which may be useful for historic showing you compliance. So those reports can be exported as PDFs, emailed. Yeah, so.
Okay, thank you. One I think for Keith here. I think it's for Keith. Someone would like to know why don't we? Well, we don't do this, but why don't airports install lightning arresters for approach light poles?
Well, it's what is meant by a lightning arrestor for a light pole. Are we talking about the pole itself, or are we talking about the electrical side of approach lights? The electrical side of approach lights is associated with the primary circuit, and there is depending whether you use, like in the US, on-screen cable when they have a counterpoise system, and whether or not they use screen cable in most of the rest of the world, where we do use a counterpoise earthing system in certain circumstances where it's an area where this is a high electrical activity. When it comes to the approach pole itself, and I guess they're talking something similar to the lightning for buildings, the lightning protection for buildings. And the reality is that if you get a direct lightning strike on an approach pole, there won't be much left. So whether you got a piece of cable or a copper taking it to Earth, it's pretty unlikely that it's going to protect an approach pole. Because I certainly know that, for example, in Singapore, which has pretty high levels of electrical activity, certainly one of the military bases. I was doing a project there many years ago, and we went in the morning and they said, oh, come and look at the approach. And we went to the approach pole, which was only around 2 meters from the ground. And there was just a scorched earth around that area. So that was a direct lightning strike. So we have a direct lightning strike on an approach pole, nothing's going to save it. Absolutely nothing. Okay? The other is indirect, when it hits the ground.
Thank you. Mm-hmm. Thank you, Keith. And one final question, because we're coming up to 3:30 here. And this is a question specifically for Africa, but I guess it applies to anywhere where the lack of energy is, where they have energy supply issues. How can you deploy an asset management system such as MALMS in Africa, where the lack of energy is not constant? So where you have supplies and electrical supply issues. Paul, could you have it?
Well, I think you know, so long as you've got the ability to charge your torque wrench and to charge your tablet, when we identify our assets, we actually use an RFID tag, which doesn't require any power whatsoever. So you can identify your asset so long as you've got a tag reader with a charged up battery. You can do your torque checking. The MALMS mobile system is powered completely by the vehicle that you're towing the trailer with, so you can do your photometric testing. And so long as you've got a 3G signal or a Wi-Fi signal somewhere at some point, then you know, as Richard I think pointed out earlier on, the information is stored on the tablet, and so whenever that power comes back, there's information from your photometric test or from your torque checking test can be forwarded at a later stage. So I would say that we wouldn't really have too much of a problem with using our system to do that.
Well, thank you, Paul. Well, it's 30:30 now. I'd like to thank you all very much, everyone that's on the call today, for participating. It really is appreciated. Without you, you know, we wouldn't be here. I'd like to thank all the panelists and Keith in particular for putting today's presentations together. And I'd like to encourage you all to participate in next week's Happy Masterclass. Get your questions in early so that Tony and the team can prepare. the best possible presentation for you. All your happy questions answered next week, and more. So thank you all very much. Have a lovely week, and I can thank you again for participating. Good afternoon.
All right.
Bye.